and I'm now talking to Kevin Montgomery, CEO of IntelliSense Technologies, which provides a global integrated monitoring service used for managing the response to all kinds of disasters, including earthquakes. Kevin is also the director of the National Biocomputation Center at Stanford University, where his team develops advanced medical technologies for NASA, the Defense Department, the National Institutes of Health, and many other organizations. He has a PhD in computer engineering from the University of California at Santa Cruz. Kevin, welcome to the program.
Thank you.
Good to have you today.
Thank you for having me.
Now, I understand that your field is disaster management. What sort of work do you do in disaster management, specifically as it involves earthquakes?
Well, specifically with earthquakes, what we've learned is that you need to integrate a lot of information to attain situational awareness of what's really going on in an area, no matter whether it's an earthquake as a disaster or any other sort of natural disaster. So specifically with the case of Fukushima and the Sendai and Japanese earthquake, what we've been able to do is rapidly integrate all of the other information that exists in the world that could be of value to let people understand what's happening on the ground there and be able to make informed decisions about that.
Now, when you say you integrate all this information, where do you get it from? What's your source?
Typically, it's a lot of different information sources that are popping up over the internet. So, for example, to relate back to the previous speaker, we automatically tap the USGS shake map and all of their sensors that exist worldwide. We also automatically tap the NOAA ocean buoy network worldwide, so we can actually watch the tsunami as it travels across the Pacific. We can tap all kinds of different information sources that exist out over the internet, but each one are in their own little stovepipes within their organizations. What our service does is it lets you integrate all of that data together to basically put all the world's data at your fingertips about any particular event.
Are you involved in generating any of your own data, or is it all gathering data generated by other sources?
No, we also have our own sensors that we've deployed worldwide that sometimes you need information about a particular area, and so you would like to be able to actually place a sensor there. So in the case of Japan with the Fukushima reactor issue, being able to place sensors actually on the ground there that are radiation detectors together that are integrated with weather stations, so you can know which direction the winds are blowing. So we also make those sensor stations, and we have them deployed worldwide for problems from waterborne illness to air quality to also radiation.
Now, don't your sensors also detect Earth movement?
They can. We can also plug in any sort of other sensor also, so accelerometers and other detection methods as well.
So these sensors all send their information electronically, so you basically have an electronic transmitter, and on top of it you can have a sensor that looks for some particular type of thing, and then it sends it to the central source.
Correct. Basically, we've made a box, an electronics box, that lets us plug in pretty much any kind of sensor, weather sensors, water quality, seismic sensors, anything, and then it can transmit that data from anywhere on the planet. But what you really need to do is integrate data together from those sensors that you know about, but also everybody else's sensors too. And the idea is, again, if we integrate all of the world's data into one place and then put it at the fingertips of those that need to make rapid decisions, then it becomes a very powerful tool.
Is it possible that there is so much data that it's hard to find what you want unless there's also a method of organizing it?
Absolutely. That's one of our largest challenges. Is our service right now has over 800,000 layers of live data streaming into it right now, and you can easily become overwhelmed by all that information. So that's been one of our big challenges we've been working on, is to call out just those layers that are really important for a particular topic.
Now, you have your laptop here, and I understand that you're going to give us a demonstration of your product. So let's take a look at what you've got here.
Sure. So this is called IntelliView. It's a worldwide visualizer, kind of like Google Earth, but different in a number of different ways. What I've brought up here is kind of a world overview, and first I thought I would take us to Japan. So this system right now is integrating online media information and all kinds of data about the situation that's occurred there. And as I turn on different layers, I can look at the affected areas within Japan and see the nuclear power plants that have been affected. In fact, let me even zoom in a little bit here.
Is this all updated automatically in real time?
Absolutely.
Without
updated live.
Human intervention?
Correct. Without any human intervention, this is all updated. So this is live data coming in from the USGS feed. Live media reports also coming in related to the nuclear reactors there. Information about from media sources also about the airport. YouTube videos, all kinds of information. So in this case, we've integrated just the affected locations. But what's also interesting is we have all of the Japanese shelters. So this is a rather large, what's called KML file, which is actually only available in Japanese. And unfortunately, I don't have the Japanese language pack here, so you can see this written in Japanese, but we do real-time translation of all of this data as well. So here, in this one portal, which anyone can go to, it's fukushimacrisis.org, you can zoom in and click on any location, and it'll tell you information about that shelter, and then integrate that together with other information that's going on.
Now, how do people access this? Is this a free service that anybody can access anytime they want?
Absolutely. So IntelliSense does a lot of environmental monitoring projects for National Science Foundation. We do other projects for other clients. But when there's something as important as Fukushima and the crisis in Japan, we absolutely put all this data out there, because through sharing information, we can all make much better decisions. So this is completely free. Go to fukushimacrisis.org and feel free to use all of the information that's there.
Now, who else uses this? For example, do public safety organizations rely on this type of product?
Absolutely. So we're getting involved more and more with disaster management. So for example, we were heavily involved with the Haiti earthquake, being able to rapidly integrate all of the information that everyone in the world had, from satellite imagery to medical facilities to where the areas of greatest damage were, and then bring all that data together and then make it available to folks at WHO, World Health Organization, Department of Homeland Security, Department of Defense, State Department, and others, so that we can manage and understand what's going on in a crisis.
So the system has been field tested already, and it's been shown to work okay.
Absolutely, it has been. In fact, what I did on this other view is I actually brought up Port-au-Prince, Haiti. So just jumping from the Fukushima crisis portal, jumping over to Haiti, during the break, I went ahead and integrated in a bunch of different information that we happen to have from there. And I can go all the way down to viewing individual satellite images and look at before and after, look at where all the medical facilities are, look at all of the tectonic plates and how that played in with the shake maps, and even manage a response.
So does this also include information like, let's say you're in the earthquake zone, you want to know what roads are still open, is gasoline available, or bridges able to be used? So it has all that kind of information. What medical services still exist, what hospitals are still open?
Absolutely. What happens typically is that different organizations will take that information and put it online on a website. But nobody's really integrated all that information together and made it easy for you to have kind of one-stop shopping to be able to get all the information that you could need. So that's really what our integration service does, is again, integrate all this information together so you can make informed decisions.
Now, who supports it all? Because you must have a fair number of employees and you must have expenses. Is the government funding it, or?
We're actually a relatively small team. We have about 15 engineers, all from NASA and Stanford, that have been developing this, and it's actually spun out of my lab at Stanford. But we have really great collaborators all over the world with different universities and different places, different government labs. A lot of our funding actually comes from the Department of Defense, but it's more for force health protection. So radiation monitoring in Japan, for example, being able to transmit medical data from anywhere in the world, being able to, again, make better decisions as a leader within the military is also important. Even real-time air quality, so that our troops aren't subject to toxins and stuff in the environment.
Now, does this help to predict earthquakes? You have all these sensors around the world which can detect earth movements. Is that helpful in indicating when an earthquake might be likely to occur? Are there certain signature types of movements that would occur shortly before a big quake?
Well, that's a good point. The next step, really, right now we're in the data acquisition phase. And as I said, a lot of data is being acquired and it tends to stay within its own stovepipes. Now that we've started to integrate things together, we can start to look at how different things are correlated together. And once we have all of that information, we can then do the next step, which is real-time analysis and modeling and looking at all of those correlations and seeing how they may impact each other.
Does this also help coordinate the disaster response, like as far as dispatching the ambulances? Where should the rescue teams go? And how can the different public service agencies coordinate with each other? Does this provide the tools to do that as well?
One of the big problems with, for example, Hurricane Katrina is that the people in Washington didn't understand what was going on the ground in New Orleans and other places. A tool like this allows everybody to literally get on the same page. And so it does allow you to communicate up and down the chain and also across organizations. So that is the next step for us, and we're talking with a number of groups about doing exactly that.
Yeah. Do you see this as becoming something that's used worldwide, or there other people doing similar types of projects? Because it sounds like it doesn't require that much of an initial investment to get started with this type of...
Well, that's what we do. We actually make this platform available to anyone that for a good cause, basically. And that's what we want to do, is to really facilitate groups of people distributed perhaps around the globe to come together and work together to solve big problems, or to manage disasters in this case.
So I think this might lead to more international cooperation in general. So for example, if people in America have a better understanding of what's going on the ground in Haiti or Japan or someplace else, they could better tailor their own response to it if they're going to have a response to it.
Well, certainly. I mean, in the case of Haiti or Japan, it's a very good example. It's a multinational effort. In the case of disasters, or in the cases of a lot of the tasks and the challenges that we face, from climate modeling and the changes that happen because of that, to even natural disasters like this. Our ability to work together across organizations is really important, and all we're trying to do is to facilitate that.
And you're the main organizer of this project, who's basically put the software together. What's your role in it?
I'm the leader of the band. I've got a great group of engineers, and again, a great group of collaborators that we work with all around the globe. And we don't compete with anyone. We just collaborate with everyone. So as I said, it looks a lot like Google Earth. Someone can use Google Earth to view this. The idea is to, again, bring people together and solve big problems and do big things.
Well, great. It sounds like you're making good strides for something that really needs to be done. I've just gotten the signal that we're just about out of time, so we're going to have to wrap the show. I'd like to thank my guest, Kevin Montgomery, CEO of IntelliSense Technologies, also my earlier guest, Gene Hardebeck of USGS. Please visit us at our website at www.futuretalk.net. This is Marty Wasserman for Future Talk. Be sure to tune in again next time, and we'll see you next time.